Good afternoon, everyone. Good afternoon, everyone. I hope everyone is well and happy. It's a beautiful afternoon. The sun is out, so it's not as cold as it was in the morning. So we are able to have a very interactive lesson. In terms of the test, I think we're just left off with the last group of questions. So I'm just gonna pop that up now. And then after that, we have a little discussion about it. And then we get into our lesson of geometric patterns. I see already I have a question, which is great. I would not really be against getting a question now, but I would answer the question now. But yeah, I hope everyone is well and happy, and let us get into the lesson. Let me get the question. Maybe it's quite urgent. Let me just get the question and then we start.
Hello, sir.
Afternoon. How are you?
I'm fine, and you, sir?
I am fantabulous.
So, sir, I
Yes.
wanted to ask you if you got the email that my mom sent. It was the test.
I've already responded to all that I've received. I've said received, and there were only two I remember of grade 6 that I had a problem with the attachment, but it was fine. But majority of them I have replied to say received with thanks.
Yes, sir. Thank you, sir.
All right, no problem. Right, so we were left off with the last part about it. The last part about the memo. I'm going to pop up the memo now. It's not going to have the text on it as the last time because it's Adobe decided to do its own way of showing it, but it's not really a train smash. So we were at the last part, the last questions. I take that we were at question 5. If I'm not incorrect, we're at question 5, I hope. And we're looking at the questions. So let me just pop this up. It's really low on my PC. I hope everyone can see Adobe Reader. I'll just resume the share. So I hope everyone can see the Adobe Reader right now. Can I just get confirmation that all of you can see? I hope everyone can see Adobe Reader. Wow, it already has the text. Beautiful. Right. I hope everyone can see Adobe Reader right now. It's the question paper. We're looking at the last question. At the last question, we covered majority of them. Most of them were, if we can just look at the last 2 questions. Can everyone see? I've reshared it. All right, so everyone can see. Beautiful. Great. I've reshared it. Let's look at the last questions. Right. So at first we were answering the fractions. We said that we have 2 methods here because both of them, if it was looking at an aspect of both of them being is still being shared. I hope we still see, right? So we're looking at both of them are over 8. Yes. All right. Good. So both of them are over 8, and then, right, good. So we can still all see. That's awesome. That is beautiful. So both of them are over 8. You can just add the two fractions, you get 20, or you can convert. The first part you can convert, you get 20 over 8 plus 19 over 8. Then you add, which is 39 over 8. Then you add 4, 7 over 8 as your mix that towards the end, right? And then or then the next question, what we said that you multiply the numerator, denominator, and then after that you simplify. So here we had 47 multiplied by 2, and I think it is 9 multiplied by 18, and then we got our answer of 94 over, I think it's 162 if I can see correctly, and then we have our final answer of 47 over, I think it's 81. Yes. And then that's how we did it. And then here would also have the same thing of saying, because there are different denominators, would have to make the denominators the same, but this would be after converting. And I hope that we see where the marks are. The marks were saying that I noticed that this fraction and this fraction are completely different due to the denominators. So I'd have to convert this first into an improper. After converting it to an improper, then I'd only start to subtract. And because this is 25, all I'd need to change is I'd have to change this 5, right? So I would first have to work it out as a mix to say it would be 22 over 5, then multiply it by 5 over 5, then I'd get what, 110 over 25, 110 minus 79 gives me 20 or 30. Let me just zoom it up a bit. There we go. So that we can see it much more clearly. Yes. Yes, so we'd have 31 over 25, and that would be 6 over 25. The mark came here to say that, look, the mark came from noticing that this one here and these two, because that's how you tell whether denominators are the same or not. It's with the how fractions are the same or not is with the denominators. That becomes our prime focus. I hope we are capturing everything. I opened it up. I made it more clear. I've zoomed in a bit, so I've made it much more clear. I hope we are getting the parts about the fractions clearly. This is the last time we're looking over the memo. So I hope we're getting the parts about the fractions clearly. I see still I have a question. So I just made I zoomed it out up a bit so you can see much clearly. Hello?
So
Yes.
on number 4.5. Oh, so never mind. That was a mistake from my side.
All right, no problem. No problem at all. No problem at all. Then we come here to number 4.5. Number 4.5 says that, look, 25 over 12 divided by 2, 2 whole number 1 over 12. The best trick is to what? I need to convert this into an improper. I find that I have 25 over 12 multiplied by 25, divided by 25 over 12. This needs to change into a multiplication because we do not multiply fractions. Then I have 25 over 12 multiplied by 12 over 25. This and this number would be exactly the same because remember, we're multiplying the numerator, denominator. And because you can see that 25 times 12 and 12 times 25 is going to give me the same number. And then, you know, a fraction divided by over another fraction, the answer is forever going to be 1. The answer forever is going to be 1. The answer will never change from 1. the answer forever is going to be 1. So because I knew that this and this number is going to be the same, my answer is 1. Simple as that. It is as simple as that. Then we move on to the next question. The next question says, there are 30 people in a bus, right? 2/5 of them get off, right? 2/5 of them get off. I hope we are correcting ourselves at the same time while I speak. Right. So I work out the of, right? I work out the of part. So I find out what is 2/5. What is 2/5 of 30? I work it out. I say, okay, 30 times 2/5, which is 30 over 1 times 2/5. Then I say the top multiplied numerator multiplied numerator, denominator multiplied denominator. It's 60 divided by 5. 60 over 5 or 60 divided by 5 is 12. Then I just do the subtraction. What is 30 minus 12? 18. So my final answer is 18. So my answer is here. My correct answer is here, here, and here. And I'm done. Then I am done. Beautiful. Beautiful. Then now we come back here to the last 2 questions. The last 2 questions is, Tembi has a toy company that has 94,824 teddy bears. How many teddy bears must be sold per month for her to finish her stock in a year? Then you just divide that by 12. You know that in long division, we divide, we multiply, we subtract, we bring down. We divide, we multiply, we subtract, we bring down. Let me say. Remember, because this is also this is a double digit, right? And it being a double digit, you can only go into 2 digits or more. So my first double digit is what? 94. 94, 12 into 94, because there has to be more than the divisor, which is 12. So 94 is more than the divisor. How many times does 12 go into 94? 94 is not a multiple of 12. So I need to look for a number before 94, which is a multiple of 12. I find 90 doesn't work. I go a bit down, 84, which is a multiple of 12. So it's 7 times. 7 times 12 is 84. 94 minus 84 is 10. I bring down the 8. Then I move along. I say 12 into 108. 12 into 108 is a multiple of 12. And how many times is 12 in 108? 9 times. 9 times 12 is 108. 108 minus 108 is 0. And I have a 0, which means I must bring down the 2. 12 into 2, because it's a brought down and it's this situation. This situation means that I have a 0 in my quotient. So I say 12 into 2 doesn't work out because we do not want to have a decimal as yet. So we put a 0. 0 times 12 is 0. 2 minus 0 is 2. Bring down the 4. 12 into 24 goes how many times? 2 times. Why? Because 24 is a multiple of 12. 2 times 12 is 24. 24 minus 24 is 0. So for her to finish her stock in a year, she must sell 7,902 teddy bears. The mark was, most marks came on the process and the correct quotient. I hope we're getting that. Are there any questions with the long division? Are there any questions with the long division? Are we fine with the long division? Do we have any questions with the long division? Do we find any problems with the long division? Are there any questions with the long division? Are there any problems with the long division? Any problems at all with the long division? I think everyone is fine. I think everyone is fine in terms of the long division. All right. Right. Let's move to the last question. So the last question was, there are 268 schools in Greenwich. Each school has 59 classrooms. How many classrooms are there in Greenwich altogether? All you needed to do was multiply 286 multiplied by 59, because that's when you know how many classrooms. Then you find out that there are 15,812 classrooms. How did we do that? We did that by multiplication. We started by the 9. 9 times 8. Okay. 9 times 8 is 72. So I write the 2, I put a 7 on top. 9 times 6 is what? What is 9 times 6? 9 times 6 is 54 plus plus 7 is 61. So then you move on. Are we getting it? Let's start. Are we getting the multiplication part? Are we getting the multiplication part? I see there's something going on in the chat. Let me just quickly get clarification from it. All right, let me start again. So there are 268 schools in Greenwich, right? There's a town in Greenwich. Each school has 59 classrooms. So I want to know how many classrooms are there all in all. So I would multiply the amount of schools times the classrooms, right? To get 15,812. How did I get that? I multiplied. So I did 3-digit multiplied by 2 digits. Then I said 9 times 8 is what? 72, right? 9 times 8 is 72. So I put the 7 here, and I put the 2, I carry 7. Then I say 9 times 6 is what? 54. Plus 7 is what? 61. So I put the 6, I have a 1 down here. 5. How are we together? 61. 9 times 6 is 54, yes. Then I say that 9 times 2 is what? 9 times 2 is 18. Remember, there's still a 6 here. 9 times 2 is 18. Plus 6 is 24. That gives me what? 2,412. Then now I'm here by my 50. So I have 0 as a placeholder, because I'm not just multiplying by any ordinary number. I'm multiplying with what? A 50. So since I'm multiplying with a 50, I put 0 as a placeholder. Then I say 5 times 8 is what? 40. So I put a 0, carry 4. 5 times 6 is 30, plus 4 is 34. So I put the 4, I carry 3. 5 times 2 is 10, plus 3 is 13. And I have my final answer here of 13,400. I add the 2. 2 plus 0 is 2. 1 plus 0 is 1. 4 plus 4 is 8. 2 plus 3 is 5. 1 plus nothing is nothing. So I have is 1, sorry. Then I have 15,812. That's how I did the multiplication here. That's how I did the multiplication. Do we understand the multiplication part? Are we still lost with the multiplication part? Because now this is the final answer. Are there any questions in relation to anything? Do we understand the multiplication part? Beautiful, beautiful. This is what I love. I see people now understand. That's all, guys. Remember what I said always, what I've been telling you, what is important. Who can tell me? I've been telling you there's one thing that is very important. There's one person who comes from a particular place that is very important in multiplication. That I said, now remember we changed him and we said he's from Newcastle, KZN. So I said there's one person who's very important to us. What is the name of that person? What is the name of that person or that thing? I always say is important that you must consider in multiplication. Even in division sometimes is also very important. What is the name of that thing that's important? Before we end off the test, what is the name of that thing? It's very important in multiplication. Very, very important. Yes. Yes. The name, I see it's Kamohelo who says the name of that person is place value. Simple as that, place value. The name of the person is place value. The name of the person who comes from Newcastle is place value. That's it. That's it. When you're multiplying by a unit, when you're multiplying by 10, once you've understood that, your life is simple. Are there any questions in relation to any other question that we've passed by so we can start with the new work? I will give you guys back your tests with everything, with my comments and everything by Wednesday. Is there any other thing in terms of the test so I can just close the test chapter? Because I need to also make sure. All right, while we're speaking about the test as well, is there any question that you guys wanna go through? Okay, so I see no, sir. So can I quickly, please, can I have a favor? All those who have written the test right now in the chat, can you please put I wrote? If you have written the test, please write in the chat I wrote quickly so I can count how many people have written the test. So if you have written the test, please put in the chat I wrote. So I have 2, right, 3. So it's 4, 5, 5, 6. All right, let me keep my count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9. I've counted 9 so far. Anyone else? I've counted 9 so far. Anyone else? I've counted 9 so far. Anyone else? I've counted 9 so far. Going once, going twice, going once. Counted 9. Or did I miscount? Let's count 1. Wait, let's count 1, 2, 3, 4, 5, 6, 7, 8. All right. Thank you so much. Thank you so much for clearing it up for me. There's 8. So I've counted 8 so far. 8 going once, 8 going twice. All right. So it's nobody else. Nobody else has written. Nobody else has written. All right. Awesome. Let's start with the new work. Let's go to the new work. Beautiful. Let's go to the new work. So we were dealing with geometric patterns and we were speaking about geometric patterns. I'd love to skip right along to say, you know, we spoke to say a geometric pattern is a kind of pattern formed using geometric shapes and a repeated design. We said there are some that are repeating and then there are others that are growing patterns, right? So I wanted to speak about rules. Now, I want to ask you guys, what are rules? When I speak about rules, when we are having a conversation about rules, what are rules? What do we mean by rules? What are rules? What are rules? What are rules? Please, can I want to know from you guys, what are rules?
Hello, sir.
Hello, how are you?
I'm fine, and how are you?
I'm excellent.
Rules are things that we are according to do.
We are?
Rules are things that we are supposed to do.
All right. Rules are things that we are supposed to do. All right, 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 all right.
So Sam,
Hello.
rules rules are the commands given us to ensure that we are safe and that we
Mm-hmm.
abide by them. And in
All right.
geometric terms, it's the way by which the geometric patterns increase or decrease.
All right. All right. All right. Repeat the last part.
So in geometric patterns terms, um,
Yes.
rules are the ways by which a pattern increases or decreases.
All right. So it's the way a pattern increases or decreases. Right.
Yes, sir.
Okay. 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 I'll take the last one, the last comment, the last one. Hello.
Pattern rules. So a numerical pattern is a sequence of numbers that has been created based on a formula or rule called a pattern rule. Pattern rules can also use one or more mathematical operations to describe the relationship between consecutive numbers in the pattern.
All right.
Descending patterns often involve division or subtraction.
All right. So it shows people did their homework, because I remember saying that research geometric patterns and rules and how do they link. And it shows that people did their homework. Beautiful. You see, so once you've done your homework, this part becomes easy because you've done half of the job that I need to do. Right. Guys, when we speak about rules in life in general or in any circumstance, we are speaking about things that you must follow to the T, right? It's something that you must follow to the T. That if you start going against the rules, you're going against even in life the social norm. So you are breaking things so that would normally lead you into a bad consequence. Hence, if you're not following the rules set by geometric patterns, you are no more following how that you're no more going the way in which you can get the next term, because rules are set in geometric patterns, or geometric patterns have particular rules in order for you to get the next term. Remember that each geometric pattern, guys, is unique to the other, right? Each geometric pattern is unique. That's one thing you guys must note. Write down. Put on anywhere on the wall, on the fridge, on your hands, that each geometric pattern is unique. Each geometric pattern is unique. Each geometric pattern is special, right? And each geometric pattern has a rule of its own. Has a rule of its own, which tells us how do we get the following pattern. Do we understand? I hope we're understanding. Hence, that's why if you read here, if you read here, if you read here, if you read here, I hope, please guys, write this down as well. Write down each and everything while I explain, or take a screenshot. Preferably take a screenshot. I use the technology as much as possible. So, if you read, you can see that some patterns you must continually multiply. Some patterns you must continually add. Some patterns you continually subtract the same number. Some patterns is that you keep on subtracting a number, but the number that you're subtracting by increases. For example, some pattern you'll find that you first had to subtract 2, then you subtract 3, then you subtract, etc. Or the other patterns, you find that, okay, at first I added 2. Then I added, for example, here, at first I add 2. Then I add 3. Then I add 4. Then I add 5. Then I add 6. Then I add 7. Then I add 8. It's like that. It's like that. But the constant thing about it, it's that rule. The rule is telling us what the way you get the following term is that's how you operate. Why is it still deemed as a pattern? It's that because it's still either, you know, that the number that you are adding by or subtracting by or dividing by has its order. And the general pattern itself, because it's a repeated thing, it's like you keep on adding. You feel it has a pattern. How do I best put the words together? That you can see that actually I'm doing the same thing consecutively, making it a pattern. And making it a pattern is that, especially here in this growing pattern, that the number that I keep on adding by, I'm increasing by 1. So it's a repeated action, making it a pattern. Are we together? I think I have a question. Hello? All right, there's no question. Are there any questions? Are we done writing this down? Are we done writing this down? Are we done writing this down? Are there any questions? Are we done writing it down? Are we done writing it down? Are we done taking a screenshot? Do we have the information? Are there any questions, guys? Because remember, you either divide or you multiply or subtract or add to get the next one. So are there any questions? Any questions at all? Does anyone have a question? Does anyone have a question? Does anyone have a question at all in regards to the geometric patterns and the rules? Because I want us to try a little class exercise. And then after trying the class exercise, we go directly into the homework. Then we go into the homework. Then we go into the homework. Are there any questions? I see that there are no questions. Let us move into the little class exercise, and then it will be homework. Right. Right. So here, as we can see, example, you add 3 to get the following number. And you don't add 3, sorry. You're supposed to add 5. So it's 5, 10, 15, 20, 25, 30, 35, 40, etc. to get the following one. Next one. Here it's what? It says the number you multiply by increasing by 1, showing the growing pattern. So here you say times 2 gives me 10, times 3 gives me 30, times 4 gives me 120, times 5, etc. As you can see along, and it's a growing pattern. I hope we are seeing this, guys. The third example, so say the dividing by, the number that you divide by increases by 1. So I start here to say, all right, what is 120 divided by, what's going on with my keypad? What's 120 divided by 2? It's 160. What is 120 divided by 2? It's 60. What is 60 divided by 3? It's 20. What would be 20 divided by 4? 5. So the following one here would be 5. Right. Here is your exercise. You have 4 minutes to do it. 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 I hope we saw the examples. The examples and what I had previously are the same. It was just for you guys to see that the picture remains the same.
Sir,
Hello?
sir, have they changed the block to privately because we can't type to everyone?
Yeah, if you have a question or anything, you can type to me directly.
Okay, sir.
All right, awesome.
Thank you.
Cool.
Sam, I wanted to say that I found the answer for the first one.
Oh no, it's fine. What will happen is let us finish. Let's get the whole 4 minutes, and then after that, you guys will tell me the answers.
Yes, sir.
Awesome. Awesome, 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 awesome. All right. 3 minutes left. Two minutes left. Two minutes left. 40 seconds left. Ten seconds left. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right. Right. Who is done? 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 Excellent. Excellent. And remember, you must also tell me the rule when you answer. Right.
Sir,
Hello.
for the first one, you add 3.
And what type of pattern
Actually,
is
you times. It's
times? Are you sure? So you're saying 6 times 3 is
no,
9?
no, sir. It's actually plus. 3
All right,
plus 3 is
plus.
equals to 6.
And what
Yes, sir.
type of pattern is it? Is it a repeating or a growing pattern?
It's a going pattern, sir.
It's a growing pattern. All right. Awesome. Awesome, 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 awesome. Let me get all the answers and I'll show up the corrections.
Can I answer the second one?
The second one,
Or should I finish the first one?
you only did the first one.
No, should I answer the ones in the first one?
No, the first one has been answered. You can answer any other one.
Okay, I wanna answer the second one, say.
Yes. The
The
second one, how do
second
you?
one it's plus. You see the number one,
Uh,
the first
uh-huh.
one. It's 1
Uh-huh.
plus 1 equals to 2. 2
Uh-huh.
plus 1 equals to 3. 3
Uh-huh.
plus 2 equals to 5.
Uh-huh.
5 plus 3 equals to 8.
Uh-huh.
Then 8 plus 5 equals to 8 plus 5 equals to 14.
8 plus
13, sorry.
13 actually. It's
Then
13. Good.
13,
So what pattern is it? What pattern is it? What name does it have? It has a very special name, this one.
it's ongoing
Once.
pattern.
Yeah, but it has a nice name. Okay, but the name of it is called a Fibonacci pattern, right? Called the Fibonacci. It's a very special pattern. But thank you for recognizing getting us the following term. Let me get the last one and then I show the answers. Hello.
Hi, sir.
Hi, how are you?
I'm good, and you, sir?
I'm great.
Okay, I'm going to answer the second last one.
All right.
So it's they are deducting by 10.
And so what? Is it a growing or repeating pattern?
I think it's a repeating pattern.
Excellent.
So the next answer would be 230, then 220, and then 210.
All right. Awesome. 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 Guys, here we go. Work with me. There we go. Here are the answers. I would have also liked if you guys could have tried also the growing patterns. I would have liked if you tried this one where you say this one 480 divided by 420 divided by 3 gives me 40, divided by 2 gives me 20. I would have loved if you guys would have tried those ones out. Would have been beautiful. I would have loved if you tried those ones out. You can just quickly take a screenshot of this so I can show you guys your homework. Quickly just get some of this information down so I can show you your homework. But I would have loved if you guys could have tried this. As we are left with a minute, let me go directly to the homework. Right. So homework is as follows. Here's your homework. Please screenshot it. all you need to do is just get the following term. If you are writing down, as some of you, I know that some might be writing down, and do this one and this one and this one and this one and this one, if you're writing down. But besides saying all of that, thank you guys so much for attending the class. Thank you for being wonderful students. If you have a test and you have not sent it to me, please, here is my email address that I'm going to put to everyone in the group. Please send me the email as soon as possible so that I can go through your test and give you feedback, because I feel that feedback is very important. Please make sure that you send me a nice email with your test, or you just send your test. There's no need for you guys to actually write an email. You can send your test, and then anything else that, if it's something urgent that you want me to speak to urgently with, there's my Twitter handle, but you can just drop me an email and drop me the email with your work, and then all will be well. Thank you guys for attending the class. Thank you guys for being amazing students. I love you all. You're all special, and I can't wait for tomorrow when we continue with some more investigating more patterns and investigating how they work. So thank you guys for attending. Thank you guys for being good students. Thank you guys for also, for us working together so beautifully. It was amazing. Thank you so much. I love you all. Bye-bye. Bye-bye.